Welcome back, Calculus 2 students. I've got another video on differential equations, probably my last for now, although I may create some videos in response to student questions later. I just wanted to give you an example that wasn't motivated by the same exponential growth models as before, just a more or less random assortment of things, but and still conforming to our separable methods for solving differential equations. So we have y prime over x minus secant y equals 0. Notice we have the x, the y, and the y prime. And then we also have an initial value here, y of 1 equals pi over 6. In order to start by separating the variables, I'm going to have y prime over x equals secant y by adding secant y to both sides. Now I'd like to get the x away from y prime, but I'd like to get the secant over on this side. So we'll have y prime over secant y equals x. Now this is actually a little bit nice in disguise. 1 over secant is the same as cosine. And so that's going to turn out to be something that's pretty easy to integrate. Remember that if we're going to integrate cosine y prime, that's the same as integrating cosine y dy. And of course, on the other side, we're going to integrate x dx. So on the left, we get sine y, and on the right, we're going to have x squared over 2 plus c. Now we can go ahead and solve this using an arcsine function. Notice the constant is inside that function as well. But we have an initial condition that we have to solve for. Let's do that now. I'm actually going to use this equation because it's going to make it easier when I plug in the values. Since y of 1 is pi over 6, that means when I let x equal 1, the y value is pi over 6. So sine of pi over 6 equals 1 squared over 2 plus c. Sine of pi over 6 is 1/2. And so we can find that, fortunately for us, c is equal to 0. If it wasn't 0, if it was some messy number, well, that's okay. You just put that back into function. But we have the luxury of writing y equals arcsine of x squared over 2. That is our answer to this initial value problem. If we were not given an initial condition, we could stop here, the solution to the differential equation. But as it is, we have this solution to the initial value problem provided. I hope this helps you get started on the homework. Make sure you post in the forum any questions you have, because a lot of other students are going to have similar questions and benefit from you asking. I will try to answer those questions as much as possible. I may at times create video responses to collections of questions just to make it easier for you guys to see what I'm trying to tell you. But I hope that helps. Later.